हेलो स्टूडेंट, वेलकम टू भाभा क्लासेस। आज आम डिस्कस करवा कॉम्बिनेशन ऑफ रेजिस्टर्स इन करंट इलेक्ट्रिसिटी। कॉम्बिनेशन ऑफ रेजिस्टर्स। सो रेजिस्टर आम दीज आर द बेसिकली conductors having high resistance. To get certain resistance, the resistance are grouped. They grouped in series or in parallel combination. Because आमे जानिचु resistance, there are a large number of applications in our daily life electronic devices, and different device रे different component रे different value रो resistance required हुए, but commercially जो resistance मिले सब बेले सामान भैल्यू रे मिलू न थाए, से गोटे पर्टिकुलर भैल्यू रे मिलता है। तेणु पर्टिकुलर भैल्यू रेजिस्टेंस पाइबा को हेले किछि रेजिस्टर आनिकी ताकू ग्रुपिंग करा जाय बा इक्विवेलेंट रेजिस्टेंस बाहर करी आमे से अनुसार ताकू यूटिलाइज करू। सेथि पई रेजिस्टर ग्रुप्ड और कंबाइंड टू दीज आर रेजिस्टेंस फ्रॉम द गिवन रेजिस्टर्स। हाउ डू वी कनेक्ट रेजिस्टर्स इन डिफरेंट कॉम्बिनेशंस? सो वी कंबाइन देम in two combinations, or mean there are two ways. One is series combination and second is parallel combination. First आमे देखिबा in series connection. So series connection means the resistance are connected one by one, means terminal to terminals are connected, then we called them series connection. एक केस रे देखिबा कंसीडर करिबा तीनटा रेजिस्टेंस R1, R2 and R3, and they are connected to a supply voltage or battery voltage V. Then you see in this case how voltage and current vary in each resistor in this combination. देखो, if a battery voltage V connected across the combination, then current I will pass through each of them, because in series there is one wire only, that is why current I will be same in all resistors, but potential differences will be different in different resistors. Jodi ame naba V1, V2 and V3 are the potential differences across R1, R2 and R3. V1 is equal to I R1, because current is constant according to Ohm's law. V is equal to IR. So V1 is equal to IR1, V2 is equal to IR2 and V3 is equal to IR3. And let V is equal to IRS. So what is RS? So RS is the equivalent resistance in series combination, or total resistance in series combination. So what will be net potential difference? That is V is equal to V1 plus V2 plus V3. Because in the circuit you see here, suppose here potential difference V1, here potential difference V2, here potential difference V3. Then total potential difference or potential drop across all resistors is equal to applied voltage. So V is equal to V1 plus V2 plus V3. If there are more resistors in series, then V3 plus V4, V5 in this way आमे करि परिबा। से अनुसार आमे देखलु V is equal to V1 plus V2 plus V3. IRS is equal to IR1 plus IR2 plus IR3. Put the value of V1, V2 and V3 here. Now you take common here I, then it will be R1 plus R2 plus R3. Then both side I cancel, then RS is equal to R1 plus R2 plus R3. In series combination, the resistance are added and get the more resistance, sum of the individual resistances in series combination of resistors. So same current flows in all resistors and total voltage V1, V2, and from Ohm's law V is equal to IR. Then if R1 is equal to R2 plus is equal to R3 up to Rn, suppose n resistors are connected in series, then we get Rs is equal to R1 plus R2 plus R3 plus Rn, that is R plus R plus R up to N, that implies Rs is equal to N into R. So, resistance will be N into R. Then V1 is to V2 is to V3 is equal to R1 is to R2 is to R3. When two resistors R1 and R2 are connected in series, so how we calculate V1 is equal to V into R1 by R1 plus R2, V2 is equal to V R2 by R1 plus R2, and in this way. So, effective resistance increases, आमे देखलु in series रे effective resistance increases and effective resistance also greater than individual resistances. तापर आमे बर्तमान देखिबा second type of combination, that is resistors in parallel. So, in this case consider three resistors, similarly R1, R2 and R3, they are connected in parallel as shown in figure. Let Rp is the equivalent resistance to the parallel combination. Here how voltage and current केमिति vary करछि देखो, तो एठी voltage battery V, applied voltage V, then suppose current I is passes through it, then here there are three wires, different wires, then current will be divided. Each different wire will come, then junction will come, then current will be divided. You see here current I1 and I2, here I3. Then when current passes, same I1, I2, I3 here combine, again it will be I, and it will be maintained. And since the battery is connected between these two terminals, suppose A and B, and voltage of the battery is V, so potential difference across each resistor will be also V, because potential difference is only two ends of the conductor. So, here two ends are maintained, so V will be same for all resistors. So, when a battery voltage V connected with the parallel combination, the potential difference across each resistor will be equal to voltage of the battery V. If I1, I2 and I3 are the values of current through the resistance R1 and R2, R3 respectively, then total current will be I is equal to I1 plus I2 plus I3. Now, according to Ohm's law, similarly I is equal to V by Rp. Rp is the equivalent resistance in parallel combination. I1 is equal to V by R1, I2 is equal to V by R2, and I3 is equal to V by R3. Now, putting in the equation I is equal to I1 plus I2 plus I3, we get V by Rp is equal to V by R1 plus V by R2 plus V by R3. I is equal to, we see that I1 plus I2 plus I3. So, I is equal to V by Rp, I1 is equal to V by R1, I2 is equal to V by R2, and I3 is equal to V by R3. Therefore, we get V all are cancelled. So, 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So, this is the equivalent resistance in series combinations. And if n resistors are connected in parallel, then we can write 1 by P, Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 up to 1 by Rn. And if R1 is equal to R2 is equal to R3 is equal to Rn, then what will be 1 by Rp, 1 by R plus 1 by R plus 1 by R up to n. Up to n it will come, that implies 1 by Rp is equal to n by R, or that implies Rp is equal to R by n. So, Rp is equal to R by n, means the equivalent resistance decreases and its value will be less than that of individual resistances. Means Rp will be less than R1, less than R2, also less than R3, and so on. There is some important points आमे देखिलु कौन in parallel combination. Summary, that is in parallel combination voltage across each resistances are equal, V1 is equal to V2 is equal to V3, total current I is equal to I1 plus I2 plus I3, and I1 is to I2 is to I3 is equal to 1 by R1 is to 1 by R2 is to 1 by R3. And if two resistances are connected in parallel, then we get 1 by Rp is equal to 1 by R1 plus 1 by R2, or 1 by Rp is equal to R1 R2, it is R1 plus R2, or that implies Rp is equal to R1 R2 by R1 plus R2. And if now we can calculate individual current in terms of I1 and I2, because we know I is equal to I1 plus I2. But here आमे देखिलु R1 and R2 are connected in parallel. So in parallel means voltage is constant. Therefore, according to Ohm's law, V is equal to IR. So I1 R1 is equal to I2 R2. Now we can write, now I2 we can write I minus I1. Therefore, I1 R1 is equal to I minus I1 into R2, or that implies I1 R1 is equal to I R2 minus I1 R2, or that implies I1 R1, you bring this to left side, that is I1 R2 is equal to I R2, or that implies if take I1 common, then R1 plus R2 is equal to I R2, or that implies I1 is equal to I R2 by R1 plus R2. So this is the expression of a current I R2 by R1 plus R2. Similarly, we get I2 is equal to I R1 by R1 plus R2. So I2 is equal to I R1 by this R1 plus R2. In case we देखिलु, the effective resistance decreases. So this is, you always remember, if two resistances are connected in parallel, we can calculate easily this value. So effective resistance is less than the least in the combination. For n identical resistors, Rp is equal to R by n. So if n wires of each resistor are connected to form a closed polygon, equivalent resistance across any two adjacent corners is n minus 1 by n into R. So it is a, remember, if important relation, if n wires each of resistor R are connected to form a closed polygon, equivalent resistance across any two adjacent corners is equivalent to n minus 1 by n into R. For n identical resistors, Rs and Rp be the effective resistances in series and parallel combination. So answer आमे देखिलु, that is Rs is equal to Nr and Rp is equal to R by n. Therefore, Rs by Rp is equal to Nr by R by N. So is equal to N square. So Rs by Rp is equal to N square. A simple example, suppose resistances 4 ohm, 6 ohm and 12 ohm are connected in series and then parallel. What will be equivalent resistance in both cases? So it will be R1 is given, that means we write given R1 is equal to 4 ohm, R2 is equal to 6 ohm, R3 is equal to 12 ohm. So now in series Rs is equal to I am जानचु formula R1 plus R2 plus R3. Therefore, it will be 4 plus 6 plus 12 is equal to 22 ohm. In parallel, it will be 1 by Rp is equal to 1 by 4 plus 1 by 6 plus 1 by 12. So we can write LCM is equal to 12. So 3 plus 2 plus 1 is equal to 6 by 12 is equal to 1 by 2. That implies Rp is equal to 2 ohm. So here you see that आमे देखा पाइलु the equivalent resistance is 2 ohm and this 2 ohm देखो it is less than 4 ohm, less than 6 ohm and less than 12 ohm. So the equivalent resistance आमे पाइबा in parallel which is less than the individual resistance. But in series combination equivalent resistance will be greater than individual resistances. So now if the resistance is connected in this way, four ohm, 6 ohm, 12 ohm, then what will be the equivalent resistance between in the circuit? So in this case, this is R1, this is R2 and this is R3. So here आमे देखिबा कोटा series और कोटा parallel. Suppose current I passes, here you see that same current passes through 4 ohm resistance, means it is in series. Then I, when now it is when go, it will be divided into 2, I1 and I2. That means those two are parallel. Again these are combined I1, I2, then it will come back to I and series is complete. तार आमे देखिलु प्रथमे 6 और 12 are parallel, then with series with 4 ohm. तार प्रथमे आमे कोन करिबा 6 और 12 भितरे आमे इक्विवेलेंट रेजिस्टेंस बाहर कर दबा इज इक्वल टू R2 into R3 by R2 plus R3. That is 6 into 12 by 6 plus 12. 72 by 18 is equal to 4 ohm. Now Rp is connected in series with R1. Therefore, equivalent resistance Rs is equal to Rp plus R1. That is 4 plus 4 is equal to 8 ohm. So the equivalent resistance in the circuit will be 8 ohm. Then suppose here we connected is a 6 volt battery. So V is equal to 6 volt. Then current through R1, we calculate individual current and total current. So, total current will be I is equal to V by Rs, that is 6 by 8, that is 3 by 4 ampere. Then current through R1 is equal to 3 by 4 ampere also. Now, current through R2 and R3 are combinedly केते आसो टोटल मिसिक आसो 3 by 4. तेणु आम देखी सारी आगुरी जानचु व्हाट विल बी I2 ना I2 इज इक्वल टू I R3 by R2 plus R3, that is 3 by 4 and R3 is equal to, it is 12 divided by 6 plus 12, 3 is equal to 9 by 18 is equal to 1 by 2 ampere. And I1 we get I1 is equal to I3 is equal to IR2 by R2 plus R3. So, I is equal to 3 by 4 into R2 is 6 divided by 6 plus 12. So, is equal to 9 by 2 divided by 18. So, is equal to 1 by 4 ampere. So, 1 by 4 plus 1 by 2 is equal to 3 by 4. So, total current. So, in this case we get individual current through each resistance, and here voltage will be voltage across R1 is equal to I R1, that is 3 by 4 into 4 is equal to 3 volt, and next voltage across 6 ohm and 12 ohm also they are parallel, it will be just 3 volt. So, 3 volt and 3 volt. So, total it will be combinedly it will be 6 volt. So, 6 volt here.